10 to the magnitude is the intensity. 10 to the magnitude is the intensity. And this is actually written over here as the intensity of an earthquake is some initial value, which is very close to 1, 10 to the m. And that's kind of what we created. So if we want to compare the intensity of the Chilean earthquake compared to the intensity of the Haitian earthquake, what we need to do is compare its initial times 10 to the magnitude divided by initial times 10 to the magnitude and see what these numbers turn out to be. Now the good news is that those I zeros are going to cancel out because we don't actually have a value for them other than being told that it's very close to 1. We'll keep it in for now, but we know that the magnitude of the Chilean one was 9.5. The magnitude of the Haitian one was 7.0. So if we can divide those two values, we have the intensity difference from a 9.5 to a 7. Is it 10 times, 20 times, 30 times? We'll see. Well, the I zeros conveniently cancel, and you can either type in 10 to the 9.5, enter, divided by 10 to the 7, enter, and then divide, or you might use a little bit of strategic subtraction of powers to say 10 to the 2.5. And 10 to the 2.5, if you grab your trusty calculator, does give us a value of 316.227 and so on. So we'll call it about 316 times as intense. So it's not twice as bad or 3 times as bad. It's 316 times as intense, which is very, very substantial. So we looked a little bit about what a logarithmic graph looks like. We learned about this thing called the loop, and it compares a logarithmic to an exponential equation form so that we can properly interpret logarithms. And then we did a little bit of evaluating and solving for x, which is really becoming a little bit of a skill. So far, we've only dealt with earthquakes and Richter scale values, but there will be more applications that do arrive. The practice is from page 380, and there are a few questions to practice as we move on to transformations of logarithms the next day.